Hello, Ms. X.
Hi.
Thank you for coming in today. Now, I saw here you were self-referred. Would you mind telling me why you referred yourself, what you wanted to cover today?
Well, I have one child who's 4 with cystic fibrosis, but I'm no longer with his father. I'm with a different partner now, and we would like to have a pregnancy, but my partner is just dead set that we could have a child with CF again, or cystic fibrosis. I don't think it will happen because I've heard that you can't. That's not how it works. But my partner wants to get more information before we have a child.
Okay. Uh, when your first child was diagnosed with CF, did you speak with a genetic counselor?
I don't. We talked to a lot of people, but I don't think a genetic counselor was one of them.
Okay. Are you familiar with the ideas of DNA carrying genetic material and genes being on the DNA? Are you familiar with these concepts? Have you heard of them before?
I have a limited knowledge. I've heard the words before, but I don't know that I can tell you what they mean.
Okay. Well, I'll just go ahead and try to help you understand those things, and we can talk through uh, where you might need some help learning. To start off with, everyone in the world gets half of their DNA from their mother and the other half of their DNA from their father. Now, this DNA, it almost comes. You can think of it as coming in two sets. You get pretty much a complete set from your mother and a complete set from your father.
Sorry.
Sorry, we'll just cut it back. So, are you familiar with the concepts of DNA and genes on DNA and inheriting things from your parents?
I have a little bit of knowledge, but I don't know that I could define them for you.
Okay. Well, I'll just go ahead and I'll try to explain to you the basics of how these things are passed on and how some of these changes can happen.
Okay.
And at any point, if you have any questions, you can just go ahead and let me know, and I'll stop right there and try to help you. We can try to work through anything that might be confusing you.
Okay.
But to start with, everyone in the world, you, me, the guy down the street, we all get half of our DNA from our mother and half of our DNA from our father.
Okay.
Now, it's not just an arbitrary half. It's not just here's a bunch of stuff from mom, here's a bunch of stuff from dad. It's basically two complete sets, one from your mother and one from your father. So in a way, you have in almost all cases, you have one copy of each gene, and a gene can be something that codes for a protein. It can be coding for any number of things. They have all sorts of different functions. But in the case of cystic fibrosis, is what we're worried about now. We're really concerned about this one gene. But generally speaking, you have one copy of any given gene from mom and one copy of any given gene from dad.
Okay.
And every once in a while, there'll be a change in one of these genes. Now, depending on this change, it can cause problems, and sometimes it won't. In some cases, a change in any one of these will result in some kind of disease or some kind of condition, and sometimes there needs to be a change in both of these. Are you okay so far? Are you following along with?
Yeah.
Okay.
Yeah, kind of.
Okay. Well, just let me know at any point.
I think I've got it okay, but I'll let you know if I get lost.
Okay. So these diseases that I talked about, one change being all you need to get the disease or the condition, that we like to call a dominant disease or dominantly inherited disease.
Okay.
If you need both copies, so the copy from your mom and the copy from your dad, to have a change, we call that a recessive mode of inheritance. Now, cystic fibrosis is one of these conditions that we call recessive because you actually need to have a copy with some kind of change from both your mother and your father to have the disease phenotype. Now, your son, whom you had with your previous partner,
mm-hmm.
He has one change from you,
okay,
and one change from his father.
Okay.
Now, that means both of you have one copy of a gene from your parent with one of these changes, and one copy without one of these changes.
Okay. So one of my parents gave this to me.
Correct.
Okay.
So you could have given him either of these genes. You just happen to give this one.
Okay.
And same with your former partner. He happened to give his gene with the change. And since you both gave the gene with the change, that's why your son has cystic fibrosis. Now, with your new partner, we don't really know anything about what kind of changes he has. We haven't done any testing. He hasn't had any children before, so we really just don't know at this point.
Okay.
So it's definitely not impossible to have another child with cystic fibrosis. It's not likely, but right now with the information we have, I can only give you some ballpark figures.
Okay. So I was wrong. I could have another child with cystic fibrosis.
It's not extremely likely, but you definitely could.
Okay.
We don't generally like to say never ever going to happen. We can try to work through exactly how likely it is to happen with your new partner, and if that's all right with you, I think that would be a good way to take the rest of this session.
Okay.
Let's start out by just talking about your new partner. What's his name?
Mr. T.
Mr. T.
Yeah.
Okay. What ethnicity is Mr. T?
He is Caucasian.
Okay. So right out of the gates, what we generally quote as just the population incidence for Caucasian, well, I was going to say Caucasian men, but really any Caucasian, is a 1 in 25 chance of having one of their genes changed for cystic fibrosis.
Okay.
Now, we already know that you have one of these changes, so we know that's the case. And
Okay.
to any child you could have with him, you would have a 50% chance of passing that gene onto the child. And under the assumption that he has, if he were to have one of these changes, he would also have a 50% chance of passing it on. So if he would have this change, you would have a 1 1/4 chance of having a child with cystic fibrosis again. However, we don't know if he does have this change, and right now we can just go on the population frequency of 1 in 25. So you actually have to take that 1/4 chance and multiply it by that 1 in 25 chance to find the chance of. Are you following?
I'm getting a little lost.
It's definitely a little.
It's a little overwhelming, and it sounds like there's a large chance. It sounds like there's, me being a 50% chance, and there's a 1 in 25 chance that he could just have the mutation.
Sure.
So, it's just a little overwhelming.
It does sound, yeah, it can be. It's a lot of numbers coming into at once and a lot of new information. It can sound like a lot at once when I'm saying 50% here and 50% here. Based on everything that I just told you, what it shakes out to, before we know anything else about him, and we can definitely learn more about him, I'll tell you about that in a second.